We are live. Hello 2B. This is 4A, and everybody say hello really quick.
Hi.
All right, we're gonna help you through the acceleration equations that we'll learn today. So our learning target is going to be how can I use algebra to solve kinematics problems, and we all came up with the essential question of how do I use algebra to solve kinematics problems. Okay.
Wow.
So today we are going to talk about, first of all, acceleration. All right. So acceleration, we kind of learned about last time. A is going to be equal to some sort of change in velocity over a change in time. Right? So this correlates to a change in velocity, right? That's what that delta means. And this is a change in time. And we saw this in our graphs, right? When we've got an increasing slope, right, we see a change in velocity, right? That's all it is. Question?
Do we put that in the formula?
No, we'll just do this in the notes part. Okay? We'll probably put some formulas back up there, though, at the end. Okay, so that's simple. That's the most simple acceleration equation that we have, okay? So let's think about, just really quickly, an example problem. We're going to do a fair amount of examples today, so this will be example 1. Alright? So we're going to use a real-world example. So last time we used a Porsche as an example. Let's say a Porsche 911 goes 0 to 60 miles per hour in 3 seconds. That is fast, right? In 3 seconds. Okay? I want to know what's the acceleration. What's the acceleration? So how do I calculate acceleration? Obviously it's a change in velocity over a change in time. So what is my change in velocity here? He went from 0 to 60, so my change should be 60 miles per hour, right? Divided by, what was my change in time? 3 seconds, right? So my acceleration should be what? 20 miles per hour, and that's actually per second. Alright, so it's not the same units we're going to use later, but that's what the units are for this one. 20 miles per hour every second. So that means every second this Porsche is going 20 miles per hour faster. Right? So after 1 second it's going 20 miles per hour. Right? After 2 seconds it's going 40 miles per hour. Right? And after 3 seconds it should be going 60 miles per hour. Right? That's what an acceleration is. Got it? Okay. So we could say, right down here, every second the car goes 20 miles per hour faster. That's what an acceleration is defined as. Miles per hour per second. Because it doesn't go 20 miles in a second. It just goes 20 miles per hour faster every second. Okay? I know. Just hold steady. Alright, so example 2. I want to know how long does it take an Airbus, which is an aeroplane, A380, these are actual data, to take off. Anybody ever done this on the runway? Little side note, anytime you're on like a Southwest flight, count how long it takes for them when they turn the engines on to the end, and it's always exactly the same time. Because I had a buddy that actually had a dad that flew 777s, and it was like exactly 36 seconds from when they put the engine on. So we're gonna figure out how long does it take for the Airbus to take off. Okay, so I'm gonna give you a couple things here though. Okay, it needs to reach a velocity of, okay, so in order to actually have lift, takeoff velocity needs to be 280 kilometers per hour. And this, by the way, this Airbus A380 is like one of the biggest planes there is. Okay. So, I know that the acceleration, okay, is equal to 1.0 meters per second squared. Okay, I know that my engine, okay, I should put that, my engine acceleration of this big ol' engine is 1.0 meters per second squared. Now, does anybody see a problem here? I'm not going to have you guys do this a ton, but do we see a problem?
It's squared.
It's squared, that's good, that's the unit. Look at this. When I'm talking about velocity, I'm talking about kilometers per hour. My acceleration is talking about meters per second. I cannot have two different types of distances right there. So I need to convert something. Okay? Yeah, so let's go ahead and change this kilometers per hour into meters per second. Okay, and the way I'm going to do that is I'm going to start down here. This is just a little side note. I think it's important for us to know how to do conversions though. So if I have 280 kilometers per 1 hour, this is the way I like to convert. I need to make this equal to 1 hour, so it cancels, right? And how many seconds are in an hour? Anybody know?
60 times 6.
60 times 60, good, which is?
120? No. 360.
3,600.
Oh, it's close.
Close. 3,600 seconds in an hour. Okay. These will cancel, right? And then I need to change the kilometers, right? Okay, so let's go ahead and just do what that equals first. If I get my trusty calculator.
Oh, so it's like in chemistry when we were doing the moles, the grams and all that.
So if I do 280, I divide that by 3,600, and that gives me 0.078. And right now we have kilometers still, but now we're in seconds, kilometers per seconds. But I still want that into meters, so I need to take away kilometers, right? So if I know that there are, I'm going to put kilometers on the bottom, so in 1 kilometer, these are going to cancel out. How many meters are in a kilometer? Anybody know? Kilo means 1,000, so there's 1,000 meters in 1 kilometer. I'm going to multiply that 0.078 times 1,000 right here,
8,000.
and I'm going to get 78. So down here I'm going to bring down, and it's going to be 78 meters per second. That's the speed this thing needs to get to take off. All right?
78. 78?
78 meters per second. Think about that. 78 meter sticks every second. It's a lot, right? It's fast. Okay, so now we can do it though. All right. So if that's my change in velocity, how do I figure out? Okay, if this is my equation, change in velocity over a change in time. What am I looking for here? I'm going to look for my time. I know my acceleration, right? Which is 1. So it's going to be 1 is equal to, what's my change in velocity? I have to get from 0 to 78. So that 78 goes on top. That's meters per second. And then I'm solving for time, right? How do I solve for time here?
Multiply by 78. To each side. Multiply 78 on each side, right?
Hmm?
Yeah. Yeah. Multiply by 78.
Multiply what by 78?
1. The acceleration.
Right, so to get it by itself, right? Multiply by 78 both sides, right? So my change in time should be what? 78 seconds. Okay? 78 seconds. That seems like a long time, doesn't it? That's a minute and 18 seconds. That's why those runways are like 2 miles long. More than that?
Does it really go that fast? Feels a lot slower than
Alright, so those are easy, right? Sorry. So those are easy. Those are just 3 variable equations, though. We're going to start going to 5 variables. We okay with that? It's going to be alright. Yeah, well.
No. No. No, it's not.
Alright, I'm flipping it over. This is what is going to be known as the big 3. The big 3 kinematics equations.
Okay, Michael.
Okay, the big 3 kinematics equations. First, let's talk about the different variables that you're going to see. You're going to see a big V with a small f down below. We call it, in science, called V sub f. But in this case, this is going to relate to final velocity. So at the end of some scenario, how fast is it going? So we're also going to have a VI. What do you think that is?
Start.
The initial velocity, or the start velocity.
That's why they call me big 3. No, it's not.
We're also going to have d, which is equal to distance. Or you could also say a change in distance. That's what that triangle means, right? Change in distance. We'll have a t, which is equal to, what do you think? Time. And lastly, we have to have an a in there because we're talking about acceleration. Acceleration. So those are going to be our variables. Alright, I'm going to go from probably easiest to hardest. Okay, but we have to use all these in order to do these problems right. So the first one, let's just write them down first. So VF is equal to VI plus A times T. Right? Anytime you just put it next to something, it's multiplication, right? VF equals VI plus AT. That's 1.
It's right there.
There you go. Yeah. Okay. Next, we're going to use D is equal to VI times T plus, my pluses will always not be curved. My T's are always curved. Plus 1/2 AT squared. Don't worry. It's not going to be that hard. And lastly, this one's going to sound scary, but it's not that big a deal. VF squared is equal to VI squared plus 2AD. Okay? Those are the big three. Alright, let's go ahead and say something here. So, when using these, the biggest issue with using these is figuring out which one I'm going to use. Okay, so when choosing, when choosing an equation, okay, obviously you must have variable you're looking for, right? So it must contain the variable you're finding, and it must contain all info that you are given. Okay? So it must contain all info you're given. That sounds simple, but you're going to want to use an equation one of these times, and it's not going to have the one you're looking for, it's not going to have something that you need. So just go down this list, okay? And when I show you how to do this, you're just going to go down this list and figure out, can I use that equation? Nope. Go on to the next one. Okay? Alright, the best way to do these and learn it is to do some examples. Ready?
Hold up. No.
I got you. I'll keep it there. Need some time? So this is example 3, right?
Yeah.
Alright, I'm going to go ahead and start writing the example, so just copy it down with me. An object starts from rest. That's important, right? With a constant acceleration of 8 meters per second squared. I want you to find the speed at the end of 5 seconds.
$800.
8.00. Okay. So just like we did the other day with the average velocity problems, take the word problem and break it down into what we know, what we don't know. Okay. So first of all, what are we trying to find here? Trying to find the speed. Okay, so the speed, I'm looking for which one of these variables up top. Yeah, my final velocity, good. I'm looking for the f. Okay, so my unknown is Vf. Alright, and then what do I know? What are my knowns? What are my knowns?
Time.
Okay, so I know time. What's my time? Where is it?
5 seconds.
Right here. So I know my time. And what else?
And you know the start.
I do know my start velocity. That's something that you're going to have to kind of get used to. If it says from rest, what's my start velocity?
0.
0. So yeah, I know my VI. And lastly, I know my A. Okay? So now, looking at my equations, I need to have one that has my variable. Alright? I'm going to go from top to bottom. Does the top one have my variable?
Yeah.
Yeah, I'm looking for VF. Good. Okay. Do I know VI?
Yeah.
Yes.
Yeah.
Do I know A?
Yeah.
Yeah. Do I know T?
Yeah.
Yep, so I can use it. I can use that one. Perfect. So I'm going to use VF equals VI plus AT. I'm looking for VF, so it's VF is equal to, what's my VI? 0, so it's not going to do anything. Plus my acceleration, which is 8. I'm going to leave out my units just to make it cleaner. And then I'm going to put my seconds there. Again, leaving out my variable just to make it easy. So, what's my answer?
40.
VF is equal to, obviously 0 plus 8 times 5 is just 40. And you need units or I will not give you points. What are my units?
40 meters per second.
Okay, I'm looking for a speed or velocity, so yeah, we always give velocities in meters per second. Okay.
Oh, wasn't so bad.
Not so bad, huh? Okay, get a little more difficult here in a sec. Now, going along with that problem, okay, let's ask ourselves, what is the distance traveled during those 5 seconds? What is distance traveled during those 5 seconds? Now what am I looking for?
Distance.
Obviously looking for distance, so my unknown is D. Okay, and now, what are all my knowns? I just found one, right? What did I just find?
Speed.
I found my final speed, so I have VF, I also have VI, and all the other ones from before. So I have my time, and I have my acceleration, right? So if I'm, what? Sorry. Yep. Is that cool? Okay. So, again, going down our list, looking back at your 3 equations, alright, can I use the top one that has VF equals VI plus AT?
No.
Why can't I use that?
You're not searching for the defining.
It doesn't have distance. I'm looking for distance, so obviously I can't use that. Can I use the second one?
Yeah. Yeah.
Right, because I have my initial velocity 0, I have time, I have 1/2, or I have A and I have T, right? Alright, so I can use this equation right here. D is equal to VI times T plus 1/2 AT squared. Okay, so now let's plug in our values. What's my VI? 0. So that's 0 times 5. That's going to cancel out, right? Plus 1/2. What's my A? 8. What's my T? 5. And don't forget the squared on that. You'll forget it. So obviously my 0 times 5 goes away. So all I have left is 1/2 times 8 times 5 squared. Anybody got that on their calculator?
8 times 25.
It's not 8 times 25.
It's 200.
4
It's
times
50.
25.
I say 50.
So D is equal to
50? 100. See the
100.
I had that.
What are my units? It doesn't matter unless I have units. Meters. Okay? Question.
All in my head.
100 meters in 1 second.
That's how much I run.
I mean, in 5 seconds.
Okay?
What did you get? 8.
Alright, last example before I let you guys kind of rock and roll on your own. It'll be fine.
What did you get 8 from?
Where'd I get 8? That was in my original equation. 8 meters per second squared, right? That's my A, my acceleration. Okay, can I take this one away?
Yeah.
Alright, new sheet here. My computer.
Sounds like what's left.
Alright. Last example. This one's going to be a little tricky. The speed of a train is reduced uniformly, which means consistently, from 15 meters per second to 7 meters per second while traveling a distance of 90 meters. Okay, I want to know what's the acceleration. I'll give you some time to write that. If you get done, start identifying what you think the variables are. You guys are doing great. To be thanks you tomorrow into the future. Alright, so what am I looking for?
Acceleration.
I'm looking for A, right? I'm looking for A. And what does this equation, or what does this word problem give me? I got, well, I got 15 meters per second, 7 meters per second, and 90 meters. So what's the 15 meters per second?
No, that's the
Well, we got two velocities, so is it,
that's the initial.
it's my initial, so VI I've got. What else?
Via
I also got my VF
and distance.
and my distance. Okay. Do I have time? Nope, I don't have time, so I gotta put it over here as well. Right? I don't have time, so I don't know time either. Alright, so it's asking for acceleration, so I need an equation that contains acceleration. All of them do, though. All of my equations have acceleration. Look back at your notes. So which of those three do you think we can use?
Not. Unless we
Can I use the second one?
Squared.
Can I use d equals vi times t plus 1/2 at squared?
actually?
If I don't have t, I can't use it, can I?
Nope.
VS squared.
So I gotta use the third one. vf squared equals vi squared plus 2ad. Right? So let's go ahead and input my values. My VF is 7, right? 7 squared, make sure you write that. 7 squared is equal to my initial, which is 15 squared, plus 2, what's my A? I don't know. So I'm going to leave that in parentheses, and my D is 90 meters. So first thing I'm going to do is I'm going to resolve all my crap. 7 squared is equal to what? 49. 49 is equal to 15 squared. 225. That's now plus. Okay, I'm going to put these two things together. What's 2 times 90?
180.
180. So let's just say 180A. I like to keep things in parentheses so I can say organized. Now, what do? Algebra.
You can,
Solve for A.
try and solve for A.
Solve for A, but it's not that easy, right? So
Subtract
So you
225.
subtract the 25.
we got to follow order of operations. So I got to subtract 225 from both sides. Who loves this stuff?
Me.
I do.
So what do I get?
I feel smart when I do this.
Negative.
Yeah, it's still gonna end up with a negative number.
Negative 176. You can keep it negative. That's good. Is equal to now 180A.
You divide by 180.
Yep. Now I divide by 180.
You're gonna get one. Negative.
Yeah, I'm gonna get a negative number. A is equal to what? Negative 176 divided by 180. A negative 0.98. Let's round that, biz. Now, that's, oh, I messed up. Negative, sorry. Meters per second squared.
Look at you.
Does it make sense to negative? What's it doing?
Going back?
It's slowing down, right? So it's going from a high velocity to a lower velocity. So it's slowing down. So basically we used every equation, right? If we use all three, we should know how to do this going forward. Okay? Questions?
Is it cool if
You
I
guys
was-
can't ask me any questions, obviously, because you're not here.
Uh-huh.
But everybody say goodbye to 2B.
Bye.
We're gonna push stop. Thank you guys. We'll see you next week. Oh, don't turn off the computer. Y'all will have a unit test next week. Okay. So
That's next week.
make sure we take this seriously, and make sure you do your homework. Okay. So if I don't see you in my office and you're struggling, it's a problem. Okay. So make sure you come and see me. All right. Bye.